Hey guys, it's Mr. Sarley. Welcome to your 7th grade YouTube homework review. And today's the first day where we're going to do this a little bit differently. So on the problems where it says watch a video for tutorial, that's where I'm actually going to make a video going over how to do that problem. The rest, I want you trying on your own, and then I'll grade them when you turn in. This way you're only kind of watching for a refresher. And then after that, you're trying strategies on your own rather than copying off what I actually did. All right, so this first problem is from the unit rate, or it's from the learning target. I can find unit rates involving fractions, and it says a vehicle used 1 1/4 gallons of gasoline to travel 15 miles. At this rate, how many miles can the vehicle travel per gallon of gasoline? So this is a great problem to put in a ratio table, and I'm going to show just a few ratio table strategies you could have used. So the problem's giving me the units gallons and miles, so I'm going to start off with those, and then I'm going to write 15 for the miles in 1 1/4 gallons. And then the problem is saying how many miles can the vehicle travel per gallon, like per 1 gallon. So that's what we're looking for. And then any strategy you want to use to get to 1 gallon is sort of up to you. I'm going to show two that you could have used. One would be, I know that 1 1/4 divided by itself is going to be 1, because anything divided by itself is going to be 1. And then I'm going to do the same to the top, divided by 1 1/4. And when I figure out what that equals, that's going to be the unit rate per gallon. So basically, the problem that I'm solving right now is 15 divided by 1 1/4. It's a fraction division problem, and for those we like to turn them into multiplication by doing multiply by the inverse, but it's hard to take the inverse of a mixed number, so instead I'm going to take 1 1/4. I'm going to realize that that's equivalent to 5/4 because the whole is 4/4, and then we have one extra fourth for a total of 5/4, and then I'm going to rewrite this problem as 15 divided by 5/4. And I'm doing that for my next step because now what I'm going to do is I'm going to write 15, I'm just going to write it as 15 over 1, it's the same exact number, I haven't changed it. But then I'm going to multiply by the reciprocal, or the inverse, same thing, of 5/4, which is going to be 4/5. Then what I can do is I can multiply the numerators and multiply the denominators. 15 times 4 would be 60. 1 times 5 would be 5. And then I'm left with 60/5. And 60/5, we can also think about that as 60 divided by 5. And if you were to do that division, you would end up with 12, or 12 miles per gallon, which is the answer to this problem. So that's one way you could have gotten to 1. I'm going to show you another way you might have thought to go to 1. Alright, so this strategy is a little bit closer to what you've been doing with percents, and I bet some of you did this anyway. So I want to get 1 1/4. I'm actually going to scale it up first and then come back down. And I want it to be a whole number, and I'm going to use a strategy that I know some people use. They see that fourth, and they're like, well, if I multiply by 4, maybe the fraction will disappear. I'm going to do the same thing to the top. So 1 1/4 times 4, well, 1 times 4 is 4. 4 times 1/4 would be 4/4, which is like another whole. So basically this is going to equal 5. And then 15 times 4 is going to equal 60. And now I can just scale this back down to the unit rate by dividing by 5 and 5. So 60 divided by 5 again is 12, and it's 12 miles per gallon. So that would be another way that you could solve that problem. So I gave you two strategies. There are many more, but what I want you to do is I want you to solve questions 2 and 3 on your own, and please show as much work as you can. Even if you're confused, you should still turn it in and just show me what you were able to figure out on your own. Alright, So hopefully you solved number 2 and number 3, and now if you were stuck on number 4, here's a tutorial because this is a different type of problem. It says Dianita buys 5 bags of M&M for $3.40. Write an equation that relates the number of bags B to the total cost C. The most common mistake that you'll see on something like this is people will just say, alright, so it's $3.40 times the number of bags equals cost. This is incorrect because we need to find out how much one bag costs. And right now, we know that 5 bags costs $3.40. Similarly, this wouldn't make any sense either. Maybe they think that it's 5 bags, so that's like 5B, but this is like saying that each bag costs $5, and you multiply that by the number of bags, which we don't know how much one bag costs. So for a problem like this, I would say what you're trying to do is you're trying to figure out how much one bag costs. And what that would look like visually is we have dollars, and we have bags, and we know that 5 bags costs $3.40. And we're trying to find the cost of one bag. So long story short, we're going to use long division so that we can do $3.40 divided by 5. And again, this is a tutorial for people who might need it. Some of you might not need to see each part of this. So if I'm trying to do $3.40 divided by 5, the first thing I'm going to notice is that 5 doesn't go into 3. So some people like to put a 0 there. And then I'm going to say, how many times does 5 go into 34? Well, 5 times 6 would be 30, and 5 times 7 would be 35. So that would be too high. So I'm going to do 5 times 6. 5 times 6 is 30. And I subtract that, and I'm left with 4. I'm going to bring down the 0. And now 5 goes into 40 8 times, because 5 times 8 is exactly 40. And that leaves me with 0 remainder. So I know that one bag costs 68 cents. And remember, I'm finding this so I can write an equation. So now that I know the unit rate, which is the same as the constant of proportionality, I can take 68 cents, multiply it by the number of bags, and it will always equal the cost. And the more high school way you might see it will be without the multiplication sign, and you just have to know that it's invisible and we're still multiplying. So that's how you solve these types of problems. Go ahead and try the rest on your own. Best of luck, and again, thank you for checking your video and getting your work done.